Is user-defined package. It's not included in the Go compiler. And it's a very simple game engine. And you can search for Google for documentation of Epiton. And I'll show you the example here for simplicity. Let's see. So here. I'm trying to copy paste just to make sure that this is not it's working properly here. But I'm going to erase. I'm going to make it as simplest as possible here. So let's start from here. Okay, so we have. So don't worry about the content below here. So just pretend I have started without anything in here. So in order to make a game, you need to define a type called struct. So struct is a type, the data type that you can define with the name that could contain any number of fields. So I'm going to make a struct type named game here, and the struct can even have no field at all. So it's a zero, there's no field inside of this game struct. The one thing good about defining this kind of struct type is that you can define a method. A method is that it's a function only used with this struct type variable. So you have, you need three type of methods, three specific type method for game struct used in the Epiton package. The first one is update method, and the second one is the drawing method. So here I'm going to erase this to make it minimum. And the last one is layout method. All right, so, and then what I'm going to do is, so this, you see that these all struct and the methods are defined outside of the main function. And I'm going to use this struct inside of my main function by calling, let me give one more step here. I'm going to define my variable g as a type of game struct. And you can see there is a and sign right here, and sign here. It means that I'm making a struct type and assign its pointer, the memory address, to the variable g. And then I'm going to feed that variable into the function run game inside of Epiton. So I saved it, and then what happens is, because I already installed the Epiton package on my computer, it automatically imports the relevant address of my Epiton package, which is in this address here. And since Epiton updated recently, and not really recently, but updated, it's into version 2, I added v2 here. And I just wrote my main function and main.go. But still, I need to update my module. The whole thing is in my module, my project. So I need to update the information about my project because I introduced a new package, Epiton. So I can do it manually, but it's rather better. It's rather desirable to do it automatically. So go to the terminal. After saving main.go, you can type in the terminal menu here, go mod tidy here. Go mod tidy. And then, since I already mentioned to import the Epiton package in my main.go file, it automatically updates my module, like here, because it requires some other dependent module. So it automatically checks all the dependency of this Epiton package. And if Epiton package is not installed on your computer, it downloads it from website to your computer. So that's basically everything in order to make a game app. That's really simple as that. Although this game doesn't do anything. It doesn't take input, nothing. It's just empty screen. So I'm going to run this. Go run main.go. Type in go run main.go, and it takes a little bit of time in order to upload or prepare it. So yeah, so then now it appears a blank screen. The blank color, the default color is black, and you see there is no pixel shown in this picture, but it's 240 by 320 by 240 because I made the layout to be 320 wide, pixel wide, and 240 pixel high. And what I have to do is modify my methods to draw something. So here, let me explain more about the methods here. There are update, draw, and layout. So you can ignore layout. It's basically about how the window size, because our game will not change the window size. So we can ignore the layout method, just leave it like this, unless you want to make your game screen bigger than this one. You see the update and draw is, so these are the methods that are used to change your game screen. So always in the 30 times per second, it runs the update function and then draw function. Update, draw, update, draw. The game engine does it 30 times per second, approximately 30 times. So basically because there is a 30 frame per second for the Epiton game engine. So it's a FPS basically, 30 FPS. And what update do is whether it takes an input or stores some data and so on. And draw function basically draw whatever you want to draw at that moment. So for example, I want to draw a point, white dot, whenever I click a mouse button. Let's make it happen here. So I'm going to close this window and okay. So draw means that I need to draw so when I click the button, not only I want to put the white color on the exact pixel that I clicked, but I want that white pixel to last whenever I move the mouse cursor to the left, to different position. So I need a variable that stores all the information about the pixel I clicked. Okay? So GameStruct now needs some field to store the pixel information. So here I'm going to use pixels to store information about my coordinate of pixels. Here, let me explain the meaning of this. The toInt means that it's the list of two int data array. Int means integer, so starting from 0. It can be negative too, but anyway. So in order to record the pixel data, pixel position, I need two integer for horizontal index and vertical index, right? And then I don't need just one storage. I need lots of storage for every pixel I clicked, right? So I need a list of two ints. So that's why I put the parentheses. But this time I don't put number inside between the parentheses because I don't know how long the list will be. So that's an indefinite list. It's called a slice. So it's basically the list of two int list of list, right? So that's the variable named pixel. And let's see, I'm going to record my mouse click every time my update function is run. So if Epiton is mouse button pressed. So there's a function, predefined function in the Epiton package that detects whether mouse button is pressed. Then this mouse button pressed function takes inputs to indicate which mouse button are you going to detect. I'm going to detect the left mouse button clicked, okay? So Epyton mouse button left is a constant. It's predefined in the Epyton package already. And then if this is true, then I'm going to get a cursor position right when I click the mouse button. And that's returned by two int value, x and y. And then I'm going to record this x and y value to my field, pixel field. Pixels, I'm going to append another element in this slice with two int array here. Remember that pixel is the two int array of two int array. So this is the element of the pixel. So that's the update part. And then draw simply doesn't care whether I detected the left mouse button clicked or right mouse button clicked. I just draw whatever is stored in the pixel field. So for every point inside of the pixel list, I take that and store it into the variable called p, and then I'm going to draw also here screen. I'm going to draw, I'm going to set the color of that pixel to be white. I think there's something, function game, draw, error. I forgot, I forgot to close the parenthesis here. Yeah, that's all. All right, so no more error here. So that's all. Okay, so I'm going to run this code again. I didn't change anything. I didn't change the main function. I only changed the update and draw. So let's run the game again. Here now nothing happens, the same thing, but I'm going to click the points and click the mouse buttons. And you can see that every time I click the button, the position where I clicked is turned into white. So each white thing is one pixel. Because I assigned 320 to 240 pixel, it's quite big pixel, right? So you can see the color pixel here, but if you enlarge the size of your screen, then the pixel becomes smaller in your screen, so you cannot see that much about what is going on. Then you can actually do this thing. So you click your mouse button, left mouse button, and then move your mouse cursor, then you can see that the point is drawn continuously, but you can see that the point is not really continuously making a curve, because every time when I click the mouse button, it just records the position and then change the color of one pixel. Okay, so instead of drawing one point, let's make a line. Whenever I click the mouse button, I want to make a line that is connecting all these points. So instead of having an array of points, I want a continuously drawn curves. Okay, let's make it happen. So let's delete this and then. All right, so what should I do in order to make a curve instead of a point? I need to connect every point near one point to the next point. So whenever we connect, I think we discussed this just before we mentioned about the line. I need to decide which pixel I need to color differently. So if I want the line connecting this pixel to that pixel, I have to decide in between which pixel should I color in white so that it looks like a line. So think about this way. So let's say this is pixel 0, 0, and this is pixel 5, 3. Okay? So this is not, 5 and 3 have no common divisor except 1. So you cannot make a pattern here. So you have to decide your way to find the list of these pixel coordinates. So let's think about this way. Suppose that you draw a straight line from 0, 0 to 5, 3 with a line in a plane, in the xy plane. So this basically y equals to 3 over 5x, right? Now the problem is you need to determine which pixel you want to draw in a different color. The best way, you can split your line from 0 to 5 into as many intervals as you want, but the most efficient way of doing this is using the maximum number of pixels on horizontal side and vertical side. So horizontally you have 5 pixels, and vertically you have 3 pixels. So you want to divide your line into 5 pieces of equal distance segment. Okay? So once you have done this, okay, so what's the next point from 0, 0? So since you divide it into 5 equal distance pieces, your horizontal distance will increase by 1. So it's a 1, 2, 3, 4, and 5, right? But your vertical distance will increase only by 3 over 5, 6 over 5, 9 over 5, 12 over 5, and 3. Okay? So you got in xy coordinate the equal distance coordinate, but you want to convert it into the pixel coordinate, which is integers. So how would you convert it into integer? Well, 3 over 5 is basically, if you round up, it's 2. So you can make it into 1, 2. But there are easier ways to do it in a computer, because you can convert any real value into integer by converting the type of data. So when you convert the type from float type to int type, what computer do is not rounding up. It discards the decimal points. So 3 over 5 becomes 0. So it's 1, 0. And this becomes 2, 1, and this becomes 3, 1, and this becomes 4, 2, and now finally 5, 3. So how does it look like? It will look like something like here. You colored here, and 2, 1 is here. So because remember, the index start from 0. This is horizontal index 2 and vertical index 1. Okay, and 3, 1 and 4, 2. That's 4, 2, right? 4, 2 and 3, 5. So that's it. So you almost look like a line. But you can't, I mean, this is not a line, but in the screen, it's impossible to make a perfect line. We just mimic a perfect line. But this is the easiest way to do it. Okay, so let's do it this way. I want to make a line make a new line whenever I click the mouse button. So there's a function that detects whether the mouse button is just clicked. So just clicked means that it will just detect whether this is the first time pressing the mouse button. And it's different from detecting the mouse button, whether the mouse button is pressed, because this function checks every time it runs the update function whether the mouse button is still clicked. But I only want whether this left mouse button is just clicked the first time. So if ebitent input util, so this mouse button just pressed is in the different package, but it's a sub-package of ebitent package. Is an input util package, and I want to detect whether left mouse button is just clicked. What do I want? If that happened, I want to remove everything stored in my pixel field. So I'm going to erase everything by assigning empty list to the field, which means that I just delete all the storage in this field. For your information, Go programming language has an automatic garbage collection, so you don't need to worry about the memory stacking here. So anyway, and then if it's mouse button pressed, then it's keep recording where the next mouse button is pressed and so on. And when it's drawing, now the thing is different. You don't want to go through all the pixel positions. What you want is the pair of points. So x1, y1, and x2, y2, up to, let's say, xn, yn. So instead of going through each pixel coordinate, you want the pair of two pixel coordinates to connect by lines, right? So I'm going to use different iteration here, this different type of iteration, which is more classical, which is going through all the least, one less than the last. So I'm increasing my index of my list element in the list from 0 to the one before the last. So if I don't have -1, I'm going up to the last, but I don't want to go up to the last because if I'm at here, I don't have next element to make a line. So I just need to stop just one before the last element. So I go here and up to here, and every time at here, I'm looking at the next element in the list. So P and Q will be the start and end of the index. So this is the pixel 1, pixel I, and this is pixel I plus 1. And I'm going to, there is a Ableton automatic the function. I haven't tried this before, but let me try this. Maybe it works. Okay, so I'm going to try this anyway. Let's draw this. Maybe I can't. Maybe it doesn't work, but let's try it. All right. So let's draw the line connecting these 2 points. All right. Okay. So let's run the main. Okay, so since I used the new package called Ableton Util here, V2 here, I'm not sure whether there's no Ableton Util, so I think it's, okay, so that makes sense. Okay, then that makes sense. So before I'm doing this, yeah, so it's actually deprecated, so it's not advised to use this method, but I don't have time, so I'm going to stick with this. But since I introduced a new package called Ableton Util, I had to tidy up my module again. And after that, when I run this code, now let me do it again. So go run main.go. Then when I click, now the line curve starts. If I keep pressing the left button and move my mouse cursor, it will give me the line. It's a curve that connects all the points that I just draw, that I swept. But if I click another point and then start a new curve, the previous curve is deleted because what I did here is in the update function, when mouse button is just pressed, I asked to clean or delete all the previous data from the pixel variable. So you can see that the new curve is starting. So there's no old pixel information stored in any of the field in the struct type. So you see, what makes the game a game? When you have a screen and user interface, that user and the player can interact with this program, that's a game. So basically, there's no goal here, but there's no fun here, but actually there is an interaction. But so this, you can call this primitive type of a game that you want to make. So from here, now we will do some more to make the game even easier or make fun to play with. So as I said, even if it's almost near the midterm. I advise you to think about what kind of game you want to make and how you're going to implement it, and we'll keep working on in the class how to use Go programming language to make a game.